Hi, this is Maggie. In this video, we're going to solve a programming problem that will require looping. Before we get started, I'm going to quickly give you some tips for how to get the most out of this video. First, if you have problem solving with Python, read up through chapter 4. If you don't have it, you can still learn a lot from this video. Open up idle and follow along with Python as I work. Sometimes I'm going to suggest you pause the video and complete some steps on your own. When I do that, pause the video and do your best to complete the steps on your own. The way to learn to program is by programming. You can watch and learn if you work along with me. Remember, you can always pause the video and try something, or go back and watch again. You don't have to wait for me to tell you to pause. There are some automated exercises in the description of this video. The exercises work with the same code or similar code to the code in the videos. After you've completed the video, try the exercises to cement the concepts in your mind. Now let's get started. We're going to solve a problem for a state legislator who is interested in calculating the average amount of recess time given to elementary school students in the state. As always, our first instinct and the first step in the problem-solving process should be to learn more about this problem. Pause the video, review the brief problem description, and think about what you do and do not know about this problem. Write down some questions that you would ask the state legislator who has requested this software. Pause now. Did you come up with some questions? To solve this problem, we need to understand how the software will be used. For example, will the data be entered by a person running the program? Or will the data be stored in a file? In what order will the data be entered? What data will be entered? And will the amount of recess time always be given in the same units? For example, will it always be given in minutes? Or will it sometimes be given in hours, and how will we know? We sit down with the legislator's aide, as she will be the person entering the data. She has already called a few elementary schools to gather some preliminary data, so she has a good sense of how the process will work. She envisions a process by which she calls elementary schools, recording the name of the elementary school, the number of students in the school, and the amount of recess time in minutes. She gives us her preliminary data to look at, in which she has substituted code names for the names of the schools. The preliminary data is Elementary 1, 404.20, Elementary 2, 753.20, Elementary 3, 158.40, Elementary 4, 31.60, Elementary 5, 244.40. As we discuss the data, we learn that she will always give the elementary school code names, as it's a habit she has for anonymizing data for analysis. The next number will always be the enrollment for the school, which will always be an integer, of course, and the last number for each record is the number of minutes of recess, which is also an integer. She will always use minutes as the unit. She would like to be able to put all of her data in a text file. Our program should read the text file and produce a one-row report with a header row and columns for the total number of elementary schools, total number of students, and the average number of recess minutes. If we calculate the output for the preliminary data, we produce a table with the three columns specified. The first row contains the headers, num schools, num students, and avg recess minutes. The second row contains the data. There are 5 schools, 1,590 students, and an average of 36 recess minutes. We confirm the output with the legislator's aide. Because we're producing a table, we will have to set column widths, so it would be a good idea to know the maximum value we might print in the number of students column so that we leave enough space. We learn that the total number of elementary school students in the state is under 70,000, which will take up 6 spaces if we format our output with commas. The final bit of information we obtain from the legislator's aide is that she might wish to add values to each record, such as poverty data, real estate value, or graduation rate, for the region served by the school, and she might wish for additional calculations and data in the table. She would like to see the version that she discussed with us first. Pause the video and take a moment to think about this problem. Our next step is to identify and select among solutions. But if you're a new programmer, you might be finding this problem a little bit daunting. An approach that we can take is to reduce the problem to a simpler problem, solve that, and then add functionality until we've solved the original problem. An advantage to this approach is that we can get a program working and tested, then add a little bit of functionality and get that tested, and each time we're building on something that already works, so we know that if there's a bug, it has to do with the new code we've added. Pause the video, review the problem, and think about how you can develop a solution to a simpler version of this problem, and then how you would add to that solution until you've developed the complete program. Pause now. So what did you come up with? There are several requirements that we can set aside to simplify this problem. One requirement we can temporarily set aside is the requirement to read the data from a file. We can prompt the user for data in the order that it will appear in the file. This saves us from worrying about file reading errors and allows us to focus on collecting the data and calculating our total and average. Once we have the calculations working, we can add in the file reading. Another approach could be to write a version that simply reads from the file and displays everything that's being read to the screen. Once that's working, we could then take the step of accumulating our totals and finally computing the requested calculations and producing the output table. If we think about processing the data by hand without a program, it might help us find other ways to simplify the problem. Let's examine the input and the output. To process the input, we're going to first read the name of an elementary school. The names of the elementary schools don't appear in our output, so we don't need to save that. However, we are going to count the number of elementary schools, so we should increment a counter. We then read the number of students or enrollment of the elementary school. We are going to be totaling that, so we should add it to our total. We then read the number of minutes of recess. We're going to be averaging that, so we'll need to create a total for that first. At this point, we've read the data for one elementary school, and we're going to go through the same process with the next 3 lines of data, representing the next elementary school, count, and total. And then the next 3 lines of data, representing elementary school 3, count, and total, etc., until we reach the end of the file. This repetition should give you the idea that you can process one elementary school in a loop, and loop for as long as you have elementary schools. We are out of elementary schools when we start to read a new record, an elementary school name, and we read the end of file instead. Once we've reached the end of the file, we divide the number of minutes by the number of schools, giving us the average recess length. We have all of the data we need for our output table, so we should print the header row and then the data row. So now that we have a rough idea of how to process the input file into the output table, we should think about how we can simplify solving this problem. Pause now. Okay, did you have some ideas? One way we can simplify this is to write a program that processes the data for only one school. Or we could simplify this by writing a program that processes all of the records in the file, but just make sure we're reading one record at a time properly until we reach the end of the file. We could choose either of these options, or perhaps you had another idea for simplifying this problem. I'm going to begin by writing a program that processes the data for one record and displays the output table. We will then wrap this code in a loop to read all of the records from the file. So let's write that. We'll start by putting in a space for the docstring. And here you should put what your professor asks, maybe your name, the date, and the assignment number, and then a description of the problem. I'll write a docstring and come back. So I've written, read elementary school recess and enrollment data from a file and produce a report including total number of students and average amount of recess time for any number of schools. File is of the form school, new line, enrollment, new line, recess minutes. When reading from a file, it's helpful to include the format of the file in the docstring or part of the program that's reading the file. And then we're going to annotate our variables. Remember, in this first pass, we're going to open the file and read from it, so we'll need to annotate a variable for the file reference variable. To do that, we'll need to import typing at the top under the docstring. which gives us some additional types that we can use for variable annotations. And we'll declare a file reference variable called school data file of type typing.text.io. We're going to read just the first 3 lines of the file, and we will assume for this first pass that our file contains this data. So we're going to read the school name, the enrollment, and the recess time. Let's annotate those variables. School name of type str or string, enrollment of type int, and recess time of type int. Now let's write a comment. Open the school data file in read mode, and for our example we'll use the sample data that the legislator's aide has given us, but we should really check with our client if they want to be prompted for the name of the file. I have the data in a file called recessdata.txt, and obviously you'll need to create a text file like this as well. Make sure it is in the correct format. You can pause the video and copy mine, and it's the same as the preliminary data from before, with each line containing a single value. So this is a good point to pause the video and write the code to open the file and read those 3 lines into the variables we've annotated, storing the data as the correct type. Be sure to test your result. I'll add another comment in for the file reading. Read school name, enrollment, and recess minutes. Write the code to open the file and read the data under the appropriate comments. Pause now. How'd you do? Did you read the data into the 3 variables and confirm that they have the correct value and that they're of the correct type? If not, pause again and make sure your result is correct. Okay, so let's write that code. First, to open the file, we'll write under the first comment, school data file, our file reference variable, equals open paren, and then recessdata.txt in quotes, close paren. We could also explicitly include a second argument, r, in quotes, indicating that we're opening in read mode, but that is the default, so we don't have to include that argument. Now, under the second comment, we're going to read the first 3 lines of the file now that it's open. And bear in mind, we are assuming it exists, and we're assuming for now that it contains 3 lines of data. When we write the final version of this program, we won't make either of those assumptions. Okay, so if we look at the text file, we see the first item in the file is the school's name, so we'll read that in. And we're not going to output that school name as part of our report, but we are going to use this variable to check if we're at the end of the file, because this is the first line of a record. So we'll write school name equals school data file dot readline. We could also strip the new line off of this by adding dot strip to the end of this line, but because we're not using this string, it isn't strictly necessary. I'm going to strip the new line off because if we were ever going to write a version of this program that does use that string, for example, maybe we'd want to print out schools with recess minutes under or over a certain threshold, then we'd want to have that name in a usable form. If we don't strip it, it has a new line on the end of the string, which can make output messy. After we've read that, we're going to read enrollment, which is the next line of the file. So I can write enrollment equals school data file dot readline, but that's going to read a string. To convert that to an integer, as we know this value will always be an integer, we can wrap int around that readline expression, giving us enrollment equals int open paren school data file dot readline open paren close paren close paren. This works just like reading input from the console. If we want to convert the string returned from an input statement to an integer, we wrap int around the input statement. Here we wrap int around the readline statement. And finally, we'll do the same thing for recess time, which is the next line in the file, and the last line of one record of school data. Recess time equals int school data file dot readline. So if we save and run this program, we won't see any output because we didn't write any, but we can then examine those variables. I'll type school name at the console and press enter, and I see elementary 1 enclosed in quotes, meaning it's a string, and with no new line at the end because I stripped that. I'll then type enrollment and press return, and I see 404, which is the second line of our file, but as an integer. There are no quotes around it and no decimal. And finally, if I type recess time and press enter, I see 20, which is the third line in the file, and again, it's an integer. So I've confirmed that I can open this file and read one record from it. Our next step could be to wrap a loop around this and read the entire file in, or it could be to create the variables that will hold the total enrollment, total recess time, and number of schools, and then produce the output table. I'm going to take the approach of writing the loop first. So compare our code to the file that we're reading from. We read an elementary school name, the enrollment for that school, and the number of minutes of recess. We then either read another elementary school name, enrollment minutes, name enrollment minutes, and eventually, instead of reading a name, we read the end of file marker after reading minutes. The file ends after the last recess minutes value. If the file is empty, then when we first read an elementary school name, we'll be reading the end of file. So the school name variable is either going to hold the name of a school or the end of file marker, and either right after we read it the first time, if the file is empty, or after we've read all records, if it isn't, we'll read the end of file marker. Now that is assuming that our file will always contain complete records. We know that our client intends for it to contain complete records, and if it doesn't, the data might not make sense, and the output might not be correct. So we're going to assume the input file is structured correctly. So back to that loop, we know that we need to read a school name and then check if it's the end of file. If it is, we're done. If it isn't, we can read the rest of the record we just started to read. See if you can construct a loop using this code that we have. Write a loop that will read until the end of the file. Test it on the data that we have, and also test it on a completely empty file. To test the loop, you will want to print the record to the screen. Otherwise, you won't be able to see that it's reading each record correctly. So I'll add a print statement after we read recess time. Print school name, enrollment, recess time. Let's run that quickly. And we can see it prints elementary 1, 404, and 20. Not pretty, but it shows us that a complete record was successfully read. So now go ahead and pause the video and write that loop. Pause now. How'd you do? If you struggled with it and ultimately weren't successful, let me give you a little hint and give you the opportunity to try again. Your loop entry condition is going to be checking if school name is equal to the end of file marker. You want to enter the loop if the school name is not the end of file marker. So if school name is in your test, it must also be in your initializer and your updater. And you're going to initialize and update by reading from the file. So in your initializer, you're going to read from the file. Then test, enter the loop, keep reading from the file, and in your updater, read into school name again. If that's helpful, pause the video and try again. Pause now. Okay, I hope you figured it out. Let's go through it. I am going to use the variable school name to control my loop. It will either hold the name of a school or it will hold the end of file marker. So after I read it, I'm going to write my loop entry condition while school name is not equal to the empty string, colon. Remember, the empty string is the end of file marker. And then I'll indent the next 3 lines. So I'll read the enrollment, the recess time, and I'll print them all out. That's one record, just like before. But now I have a loop, so control is going to return to the loop entry condition. Before it does that, I want to read the next line of the file into school name. Either I'll read the next school name, as when I finish reading the record for elementary 1 and move on to the record for elementary 2, or I'll read the end of file marker, as when I've finished reading the record for elementary 5. Of course, the file we'll be reading from eventually, when we have all the data, will be much longer, but it will always be of the form school name enrollment minutes over and over until we're done. So after I print the school record, I'll repeat the line school name equals school data file dot readline dot strip as the last line within the loop. So we read a school name and we check end of file. If not, we read the enrollment and recess time for that school and print it out. Then we read the next school name and check end of file. If not, we read the enrollment and recess time for that school and print it out. Then we read the next school name and check end of file. You get the idea. We keep going until it actually is the end of file. When that happens, the loop ends and we'll proceed to the first line of code after the loop. We don't have anything there yet, but soon we'll be printing out our summary table. For now, let's run this and see if we get a single line summarizing each record in our file. We do get a single line, and if we compare to our data file to make sure that the correct data is together on a line, for example, elementary 4, 3160, we see that it is. I should probably update that comment over the loop too. I'll add for all records in the file. So it reads, read school name, enrollment, and recess minutes for all records in the file. Okay, next step. Here's where we're going to collect information for our summary table. We need to count the number of schools, total the enrollments, and also total the recess minutes so we can compute an average. I'll write the code to total the enrollments. And then we'll pause and see if you can complete the rest. If you think you can complete this step right now, please pause the video and do the whole thing on your own. I'll give you a hint. You're going to want some accumulator variables. So let's first annotate an accumulator variable to hold the enrollment total. An accumulator is a variable role. It's a variable that helps with a particular kind of processing that needs to be done. When we need to accumulate some value over the course of a loop's execution, we use a variable in an accumulator role. So I'll annotate a variable called total enrollment, and that will be an int because the values that we're totaling are all ints, and I'll also initialize it to 0. So we are going to add to it each time through the loop. So we need it to start out with nothing in it. So total enrollment int equals 0. I'm going to change the comment to read annotate and initialize variables. And then down within the loop, after we read the enrollment, I'll add it to total enrollment. Total enrollment plus equals enrollment. And then after the loop, I'll print it out so we can see the sum of all the enrollments. When we run it, we see a total enrollment of 1590. And if you recall our sample output on this data, that is the value we calculated. So it's correct. Okay, now it's your turn. Pause the video and add accumulators to count the number of schools and to total the recess time. Then print them out after the loop has finished executing. We know that there should be 5 schools, but you'll have to total the recess time using a calculator or by hand before you run your program so you have a value to compare your result to for the total recess time. Pause now. How'd you do? I'm going to first annotate our 2 new variables, and I'll call them num schools of type int, initialized to 0, and total recess minutes of type int, initialized to 0. In the loop, just as we did with total enrollment, I'll add the recess time to total recess minutes right after we read recess time. Now, what about num schools? This is just a simple count, so we want to add 1 to it every time we go through the loop. If we never enter the loop, if the file is empty, it will be 0, which will be correct. There will have been 0 schools in the file. Otherwise, each time we enter the loop, it will be incremented by 1, and we only enter the loop when we've read a school name, so it should accurately count the number of schools. I'll do that at the top of the loop. Num schools plus equals 1. For the print statements at the end, I'm going to give them labels so it's clearer what each number represents. So I'll add the label total enrollment to the existing print statement, and then I'll add 2 more, 1 for number of schools and 1 for total recess minutes. And before I run that, I'm going to add up the recess minutes. We have 20 plus 20, which is 40, 40 plus 40, which is 80, 80 plus 60, which is 140, 140 plus 40, which is 180. So we expect to see 180 for that value. When I run the program, I get the correct values in each of my accumulators. We are truly in the home stretch now. We only need to calculate the average, which is the total recess minutes divided by the number of schools, and print out the table. As a reminder, we want the table to have a header row and columns for the total number of elementary schools, total number of students, and the average number of recess minutes. The first row headers are num schools, num students, and AVG recess minutes. The second row contains the calculated data. Pause the video and write the code to complete the table. Annotate a variable for average recess minutes, calculate the average recess minutes, and produce a table. A column width of 15 for each column should work if you abbreviate number as num and average as AVG. Be sure to check that the number of schools isn't 0 before computing the division so you don't get a divide by 0 error. Remember that an empty file will result in 0 schools. Pause now. How'd you do? Did you get the correct output in table format? Let's write this together. I'll first annotate the average recess minutes variable as a float. That will be a float because it's going to store the result of a division. I'll initialize it to 0 because if there's no data in the file, I won't be computing the division, and this will be 0. Now, I'll remove the print statement from the loop because we're now going to print in our final form after the loop. After the loop, I'll write a comment, compute the average recess minutes if there was any data. How do I know if there was any data? If num schools is not equal to 0, otherwise it's 0 and I don't want to divide by it. So if num schools is not equal to 0, average recess minutes equals total recess minutes divided by num schools. And then I'll write another comment, print the summary table of data from the file, and I'll have my first print statement, which is the header. I'm going to write print and then a format string. So at first, I'm just going to write quotes with 3 sets of curly braces inside. That's where the header strings will be interpolated in. And then after the close quote, I'll write dot format open paren, and then the three headers I want interpolated in, separated by commas. Num schools, num students, and average recess minutes. Close paren for format and close paren for print. I'm going to copy that and paste it below. But this time, instead of interpolating in the strings, I'm going to interpolate in the variables holding the appropriate values. So, num schools, total enrollment, and average recess minutes. Now, within those curly braces, I want to write format specifiers that will give me a table with left-aligned data with a width of 15. So for the headers, within each set of curly braces, I'll write colon, left angle bracket, 15s. The colon is the start of the format specifier. The left angle bracket means left aligned. The 15 means that after the string is interpolated in, whatever is left of the 15 spaces will be padded. So in other words, num schools is 12 characters, so the 3 left over will be spaces. This is what makes our columns line up. And finally, the S means I'm interpolating in a string. So for the data, I'm going to use something similar, except I use D for the two integers. So colon left angle bracket 15D. And for the float, I'm going to specify 1 decimal place. So colon left angle bracket 15.1F. And if I run that, I get a very neat table with the correct values, which we had previously calculated when we sat down with the client. I've created another text file which is empty called empty.txt. If I change my program to open empty.txt rather than recessdata.txt and then run the program, my output is a table with zeros. So no crashes. We can find out from the client if this is appropriate when we show it to her. We might want to make 2 final enhancements to this program before we show it to our client. Let's prompt the user for a file name and use that file name. And let's check that the file exists before trying to open it and read from it. This is especially important when we're getting the file name from the user, as they may mistype the file or forget to put it in the directory with our program. To obtain the file name from the user, we'll need to annotate a string variable and read the file name in with an input statement, then use that file name in our open statement. Before we do that, though, if we want to determine if the file exists, we will need to use the OS path library. If the file exists, we can proceed with our program. If the file does not exist, we can print a message to the user. Pause the video and write the code to obtain a file name from the user and check if the file exists before opening and processing it. Pause now. How'd you do? Did you test your program with a file name for a file that doesn't exist and the file name for the file that contains your data? And does your program process the data for a correct file name and print a message for the user for an incorrect file name? Let's add these changes in. We'll begin by importing os.path, the library we'll use to check that the file exists. Let's then proceed top to bottom and annotate a string variable for our file name, which I'll call file name of type str. Now, before we try to open the file, we'll prompt the user for the file name and use that instead of empty.txt or recessdata.txt. So I'll write a comment, obtain the file name from the user, and then I'll write an assignment and input statement. File name equals input. Please enter the name of the data file with the .txt extension. I think it's helpful to let the user know whether you are expecting the extension or not to prevent errors. Remember that the input function returns a string, which is what we need, so we don't try to cast that to another type. Now we'll check if the file exists using the os.path library. We'll write if os.path.isFile, file name, and then we can indent all of our code that we already wrote to open and process the file, because we're going to open and process the file if the file exists. We just need to then replace the hard-coded or literal file name with the variable file name, which holds the user's input. And then we'll add an else at the very end, the same level of indentation as our if, with a print statement with a message, something like file name doesn't exist. We'll concatenate in the file name the user gave us so they can confirm what they typed. Let's test that with recessdata.txt, empty.txt, and then a bad file name. So it works the same as before with recessdata.txt. And we get the table with zeros again for empty.txt. And let me type bad.txt now, which is not the name of a file, and my program tells me bad.txt does not exist. And that is this problem solved. It may have seemed an intimidating task at first, but by developing it one small piece at a time, we were able to build a complete solution that we can now show our client. You might try adding some enhancements to this program. For example, see if you can enhance the program to identify the number of schools with recess minutes over a certain threshold, such as 30 minutes. You could obtain the threshold from the user, or count the number of schools with recess minutes over several thresholds and print all of this data as columns in your summary table. You could also add data to the records in your file, such as graduation rate for the region or poverty rate. Many states publish this sort of data about their schools, so you could look at the data your state education department publishes to get an idea of what data is collected, and add the data to your text file and then think of an interesting way to process it. For example, you could compute the average minutes of recess for schools with a graduation rate under a certain threshold, and compare to the average minutes overall. The legislator might find this data interesting if she's interested in increasing graduation rates in her state. Does recess time in elementary school correlate with high school graduation rates? You now have written a complete program requiring reading and processing data from a file in a loop. I recommend that you close your script window, open a new one, and rewrite the program yourself from scratch. Check back with the video or the program you wrote earlier only if you get into trouble you can't get out of. Once you've completed that, you're ready to move on to solving your own looping and file processing problems.